Right now, as we speak, deep inside the machines that power our world, in power plants, on oil rigs, there's a hidden battle being fought. It's this silent, constant conflict against an enemy that can literally bring an entire operation to a screeching halt. We're going to dive into the world of industrial descaling.
All right, so here's our game plan. First, we're going to get to know the enemy, this unseen clog. Then we'll do some recon. We've got to identify the intruder. After that, it's time for the main offensive, the chemical attack. We'll see how that stacks up against a more physical approach. And to wrap it all up, we'll talk about the ultimate strategy, a proactive defense so this whole fight doesn't have to happen again.
So first up, let's talk about this silent saboteur. This is the stuff that quietly costs industries billions of dollars in lost efficiency, not to mention catastrophic equipment failures. It's a relentless enemy known simply as scale. So here's a funny question for you. What does a massive oil rig have in common with your little coffee maker at home? It sounds like the setup to a bad joke, right? But the answer is actually fascinating. You know that white, crusty stuff you have to clean out of your kettle? That's limescale. And believe it or not, it is the exact same enemy that these massive industries are fighting, just on a much, much bigger and more dangerous level. So what is this stuff really? Well, at its most basic, scale is just a buildup of hard mineral deposits. See, water, especially hard water, is just full of dissolved minerals. But when that water gets heated up or the pressure changes, all those minerals suddenly have nowhere to go. They literally fall out of the water and start sticking to any surface they can find, building up layer after layer into this rock-hard coating. And this right here really shows you the danger. This buildup is like cholesterol clogging the arteries of industry. It chokes the flow in pipes, it makes pumps work way harder than they should, it stops heat from transferring, and eventually it can lead to a total catastrophic failure of the equipment. We're talking incredibly high stakes. Okay, so we know what the enemy is, but you can't just charge in blindly. To win this fight, you've got to do some intelligence gathering first. It's basically detective work. You have to identify the specific kind of intruder you're up against. And here they are, the most wanted list for the oil and gas world. You've got your number one usual suspect, calcium carbonate, that's the most common one. But then you get into the really tough characters, like the sulfates that just laugh at acid, or silica, which is this incredibly hard, almost glass-like deposit. Each and every one of these villains needs a totally different strategy to take them down. And this is exactly why the first step is always analysis. The pros will actually take a sample of the scale to figure out its exact chemical makeup. I mean, think about it. You wouldn't try to open a lock with the wrong key, right? It just won't work. And you can't expect to dissolve tough barium sulfate with a chemical that's only made to deal with simple calcium carbonate. You gotta match the solution to the problem. So once the enemy's been identified, it is time to choose your weapon. And that brings us to the most common strategy in the descaling playbook, a targeted chemical attack. This table pretty much lays out the arsenal. For your standard calcium carbonate, you bring in the big gun, hydrochloric acid. If you need something a little safer, there's sulfamic acid. For really sensitive jobs where you can't use acid at all, you use these really clever things called chelating agents. But what about those super tough sulfates we talked about, the ones that are acid resistant? Well, this is where the chemistry gets really smart. Since you can't attack the sulfate directly with acid, you do this little two-step maneuver. First, you hit it with a special chemical that actually converts the tough sulfate into a much weaker carbonate. Then, you come in with a standard acid but can dissolve that newly transformed scale no problem. It's just a brilliant tactical move. But, chemicals aren't the only option on the table. This whole battle often comes down to a fundamental choice. Are you going to go with brute force, or are you going to launch a precision strike? On one side, you've got pure brute force. We're talking high-pressure water jets, massive industrial drills, scrapers, things that physically blast or grind the scale away. It's great for really thick, heavy buildup. But on the other side, you have that precision strike. Chemicals that can get into every nook and cranny that a drill could never reach, dissolving the scale from the inside out, usually without even damaging the pipe itself. But here's the secret. The best operators know it's not about choosing one or the other. The absolute best strategy is usually a combined arms approach. You go in with the heavy mechanical tools to clear out the big chunks, and then you follow up with a chemical wash to finish the job and get all the hard-to-reach spots.
It's truly the best of both worlds.
Okay, so now we've reached the final and honestly the most important phase of our entire strategy. After all this talk about attacks and brute force, the real victory isn't about winning the battle. It's about making sure the battle never even starts. This quote just nails it, doesn't it? The absolute best way to win the war against scale is to make sure it never begins. By treating the water before it gets into the system, by carefully managing temperatures and pressures, and by using special chemical inhibitors that stop minerals from building up in the first place, you defeat the enemy before it even has a chance to form.
And when you really think about it, this whole thing is a powerful lesson in being proactive instead of reactive. It really makes you wonder, right? If these huge industries can learn to get ahead of these massive, hidden problems, what are the unseen clogs maybe building up in our own work or in our own lives that a little bit of prevention could solve completely?